Okay, so this is worksheet number 7, and I've already filled in the worksheet, so I'm going to just talk over it to uh, if there are any blanks to fit in, or in case if you want to check the video so you know how it is solved. So the first question is about the redox. So I told you about the rules for finding the oxidation state. You can find the oxidation state of each element in the product and in the reactant. So we see the standard state of oxygen and nitrogen in here. So oxygen and nitrogen are in O2 and N2 in reactant and product. So nitrogen in products and oxygen in reactant are 0. Hydrogen is with nonmetals, so in both cases it's +2. In product, oxygen, as we said, it's most of the time it's -2. And in reactant, the nitrogen, we have to find the oxidation state for nitrogen, knowing that the sum of a molecule, the oxidation state of all elements should be 0. So it's -3. And nitrogen, going from -3 to 0, it's going up, so it's oxidized. And oxygen, going from 0 to -2, it's going down, it's reduced. So the number is reduced, so the oxygen is reduced. And nothing happened to hydrogen, so it's neither the reducing agent and oxidizing agent. We said that the oxidizing agent is the one which is reduced, and reducing agent is the one which is oxidized. But nitrogen is oxidized, but when we say agent, it's basically the whole compound, okay? The whole compound acts as an agent. So we cannot say reducing agent is nitrogen. Well, it is nitrogen in the NH3, so the reducing agent is NH3. And the same with the oxygen, oxidizing agent is O2, is the molecule. Okay, so next question. So I have to move it like this. Next question, we have a limiting reagent problem. So we have the mass of 2 reactants, and we have the balanced chemical equation. So what do we want? Do we want a theoretical yield of SO3 and also how many grams of the excess reactant? So we have to find the limiting reagent first, then the other one should be in excess, and we have to figure out how much is in excess. So as I told you before, we have to start from both of the reactants and see how much product we make. We know you cannot relate mass directly to each other. You have to go to the mole bridge. So you go to mole of, let me zoom in. Okay, now it's better. So we have to go from mass to mole, then from the mole bridge we can go from reactant to product or reactant to reactant. So we use the mass, the initial mass of both of the reactants, and see how much product we make. For oxygen, for 100 gram of oxygen, we made 500 gram of product SO3. With 90 gram of SO2, we make 112.5 gram of SO3. Therefore, SO2 is our limiting reagent, and the mass of product that we make with the limiting reagent is the theoretical yield. Therefore, 112.5 gram is the theoretical yield. The second part of the question is asking about how many grams of excess reactant. So the limiting reactant is SO2 and the excess reactant is O2. First, we have to see how much of the O2 we used up. So we use stoichiometry, the same method we used to go to the product. Now this time we use it to go to the mass of oxygen, which tells us how much oxygen is used up. So we start with a 90 gram of the SO2, which is the limiting reagent, and we move to a mole of SO2, and then from mole of SO2 to the mole of O2, and from mole of O2 to the mass of O2, and we end up with a mass of O2 which is used up. So we used up 22.48 gram of O2. And how much is in excess? So initially we had 100 gram and we used up 22.48 gram. So we have 77.52 gram excess of oxygen. Okay, so the next question is we have the same reaction, and again we have two amounts of product, two amounts for reactants, and we have to find the theoretical yield and how much excess of the reactant. So to find the theoretical yield, we have to use both of these masses, both of these reactants, and see how much product each of them make. The one that makes less product is the limiting reagent, and the amount of product with the limiting reagent is the theoretical yield. You see that with 80 gram of SO2, we make 100 gram of SO3, and with 15 gram of O2, we make 75.1 gram of SO3. So since oxygen is making less product, oxygen is the limiting reagent, and the product that we make with the limiting reagent is the theoretical yield. Therefore, the theoretical yield is 75.1. For the second part, how much is excess? We have to start with the mass of the limiting reagent using stoichiometry and see how much of the excess reactant is used up. So with 15 gram of O2, 60.1 gram of SO2 is used up. So how much is in excess? The initial mass was 80, so you subtract it from what is used up, and 19.9 gram of SO2 is remained in the reaction. So question number 4, the same thing. So we have the chemical reaction. So the way we determine the limiting reagent is to using stoichiometry, going from that reactant to see how much product we make. But for reactions like this that we have two products, what should we do? Well, it doesn't matter which of those two products you're choosing. Both of them, any of them should work, okay? I chose CO2, but you can do it with H2O, with water. It doesn't matter. And both of them should, the number is going to be different, but the fact that you want to find the limiting reagent, that one of them should make less product, is going to be the same. It's not like if you choose water, at that case, then CH4 is going to be the limiting reagent. No, that's not going to happen. So in both cases, you're going to get the same result. Different numbers, but both of them, O2 is going to give you less product. Therefore, O2 is the limiting reagent. The other thing that you've noticed is that I stopped at the mole of CO2 and I didn't find the mass of CO2. That is because to find the limiting reagent, we have to find how much product it makes, okay? When we say how much, it could be mass or it could be mole. It doesn't matter. As long as both of these products, like you do it both for CH4 and O2, both of them, comparing them with the same unit, it should be fine. For the previous question, it's just because the question was asking about the theoretical yield, and theoretical yield is the mass of product with the limiting reagent. So we had to find the mass of product anyway. So I went ahead and find the mass of product for both of them. But for this one, since we don't want the theoretical yield, I just stopped at the mole. So oxygen makes less product. It's 0.25 mole of CO2, and therefore O2 is the limiting reagent. To find the excess, you use the limiting reagent, which is O2, and you use stoichiometry going to the mass of the other reactant, which is your CH4. So you see that 4.0 gram of CH4 is used up. So the excess is the initial mass, which is 16 minus 4. 12 gram of CH4 will be in excess. Okay, the next question. So again, we have a chemical reaction, 12 gram of CO2 and 8 gram of water. These two make 7.5 gram of glucose. So we want to find the percent yield. In order to find the percent yield, we need actual yield and theoretical yield. So when the question is giving you the mass of product which is obtained, it's basically the actual yield. That's the actual amount that they obtained from this reaction, so that's the actual yield. Theoretical yield is the one that you calculated with stoichiometry, okay? So in order to find the theoretical yield, as you said, theoretical yield is based on the limiting reagent, so you have to find the limiting reagent as well, because you have the mass of two reactants, right? So you have to do this for both of the reactants, for CO2 and water, and see how much product you're making. So from 12 gram of CO2, you make 8.19 gram of glucose, and for 8 gram of H2O, you make 13.3 gram of glucose. So CO2 gives you less product, therefore CO2 is the limiting reagent, and the mass of product with CO2 is the theoretical yield. So therefore 8.19 gram of glucose is your theoretical yield, and your actual yield is already given in the question, it's 7.5. So we just divide the actual by theoretical times 100, and that is 91.6. And the last question is a neutralization question. It's a titration. So you have the volume and the concentration of the acid. You also have the volume and concentration of the base. Okay. So you're mixing these two, and if you've read about titration, you continuously add one of the solutions from the burette into the beaker or the flask, and you're swirling it. So it goes on until the equivalent point where the amount of H plus and OH is equal. And when you're adding more, considering acid to be in the burette, it could be in either way. It could be acid in the burette or base in the burette. So if you're considering acid in the burette, so if you continue adding more and more, after the equivalent point you will have some excess H plus. Okay, so in this question you have been given the volume and the concentration for both acid and base. Okay, so we want to know if this is after the equivalent point, so we have excess of the acid, or it's before, or it's right at the equivalent point. Okay, to make it simpler, we can fill in this chart. So the first column we write the ions. Here I wrote the chemical equation for this neutralization reaction. Okay, so we have concentration and the volume of each two acid and base. Okay, so let's find how many moles of acid and how many moles of base we have. So for acid, if you multiply the volume by the concentration, it gives you the moles of the acid. So we will have 0.4655 mole of H2SO4. And you know that each I would say each molecule of H2SO4 has one SO4 and two H plus, right? So therefore 0.4655 mole H2SO4 will have 0.4655 moles of the sulfate and twice that number for H plus, because each of them makes 2H plus, right? Because it's H2SO4, right? So each molecule makes 2H plus molecule, 2H plus ion, and the initial number of moles of H plus is that number times 2, which is 0.931 moles. The same thing for potassium hydroxide. Potassium hydroxide has one potassium and one hydroxide, so the number you get is for both potassium and hydroxide. So in the first column of the chart, we write in the initial moles. So does the concentration change? If you write the net ionic equation for neutralization, you know it's H plus OH gives you water, right? So the sulfate and potassium are spectator ions. Spectator ions, the concentration doesn't change. They're just there. They're in the solution, okay? So it's no for the spectator ions and yes for H plus and OH. How much does it change? Well, it depends how much OH and H we have. The one which is smaller is the change, because when you have H and OH, they're going to react and make water, and they're going to continue until one of them is going to run out, and that would be your limiting reagent, right? So you have 0.18 mole of OH but 0.931 mole of H, so you have more H plus than your OH. So the change is going to be to the point that you use up all your OH, right? So the amount of change is the amount of OH you have. So how much change? 0.18 for both of them, right? So the final amount of moles for OH is 0 because you used up all of it. For H, which is your excess reactant, air quotes, excess reactant, so how much left is your initial minus the change. So it's 0.931 minus 0.18, and that will be 0.751 moles. So that's your final amount of H plus. We are trying to find the concentration of the acid of the H plus in the end. So concentration, molarity, is mole over liter, right? So we have the number of moles. What is the liter? So basically we just add these two solutions together, right? So right now the total volume is the sum of these two volumes. So we have 0.95 and 0.9, so we have to add them together, and that's the total volume. So the concentration of H plus is the number of moles, which is 0.751, divided by the total volume, which is 0.950 plus 0.900 liter, and that will be 0.406 mole over liter. And that's the final concentration for the H plus after neutralization.